Welcome. The topic we will be discussing in this lecture is file system implementation. So under this chapter, we will be discussing these topics: file system structure, the implementation of the file system, directory implementation, and allocation methods. I mean, how storage is allocated for directories or for file system. Objective of this chapter is to describe the details of implementing the file systems and the directory system. And also we'll be discussing how storage blocks were allocated for directory and for files. So as we have already defined, a, a file is nothing but a logical storage unit, and also we can say that a file is a collection of related information. And actually the files reside on the secondary storage device. See, like how in the memory we have discussed that there is a logical representation of the memory, and the physical representation of the memory differs from the logical representation. I mean the main memory. So this concept of logical and physical storage, it is applicable to disks also. When the file is stored in the disk, that is in the secondary storage devices also, the actual physical storage may differ from the logical storage. Okay, so how is that we'll be discussing in this topic. And data transfers in disks happens in terms of blocks of sectors. Okay, when we say about data transfer in memory, we say that the contents is transferred this many bytes. When we use the term bytes, the data transfer is this many kilobytes, this many megabytes, or this many gigabytes. So basically we use the term bytes to represent data transfer from or to main memory. Okay, whereas the data transfer in disks from or to the disk to the secondary storage device or mentioned in terms of blocks, where what is a block? A block is a collection of, normally one block will be equal to 512 bytes. Okay, so in this chapter we'll be using the terms like blocks of data transfer. So whenever the term blocks comes, you should understand that a block is nothing but it is equal to 512 bytes. And with respect to disk, we say we use the term block rather than bytes. Okay. And another important thing you should know is there is a the logical storage of the disk is different from the physical storage. Uh, this is something similar to in memory also. In memory also, the logical memory is different from the actual physical memory. So here also we'll have a different logical storage and different physical storage. Okay. There will be for every file, there will be something called as file control block, FCB, which contains the structural details all about a file, which contains all the structural information about a file. And so basically, the file system is organized into layers. The accessing the file system is organized into several layers. These layers are represented like this. See, so this is the layered representation of the file system. Uh, so what this diagram shows in the sense, actually the files are stored in device in the sense hard disks. Okay, and on top of the hard disk there will be some controller. So this controller will be able to directly access the contents of the file, like in which sector it is or in which track it is. Like that, this controller also will have some softwares which we call it as device drivers. These controllers will have some softwares which we call it as device drivers. Through these device drivers, these controllers can communicate with the actual disk and it can access the actual file system. like in which sector it is, in which track or in which cylinder, like that. The real access happens to the through the device drivers. Okay, so this is one level of abstraction. This is one level of abstraction. The actual content is stored in the disk, which we call it as device generically, and it is accessed through the device drivers which are present in the device controller. Okay, on top of the device controller, we'll have something called as a basic file system. So this basic file system, what it will give in the sense, it will give the instruction. From here only the device driver gets the instruction like which block is to be accessed. So the basic file system will say that we want to access block number 832, like that. So whether access means whether it is a access can be either a read operation or a write operation. These inputs will be coming from the basic file system. So basic file system will say that the a particular process would like to perform a read access on block 832, like that. Okay, then the device drivers, which is stored in the uh, which is stored in the device controller, will convert this block number to the respective sector number and platter number or whatever it may be. Accordingly, then it will access. Okay, and then on top of the basic file system, we have something called as file organization module. File organization module. So this file organization module is the one which maps the logical storage to physical storage. So this is the one which maps the logical storage to uh, physical storage. Okay, so what is logical storage? We'll come to that. But as of now, you understand this. The file organization module is the one which will map the logical storage information, which will map the logical storage information to relevant, the equivalent physical storage information. Okay, and then on top of the file organization module, we have logical file system. Okay, so this logical file system is something which maintains an FCB, file control block, for every file. The logical file system is the one which maintains the file control block for every file. Okay. On top of this, we have the application programs. So the application program can be any software that is used by the system. Okay. So this application program will simply say information like this. I want to access the file, say file one.txt. I want to access the file one.txt, which is present in say so and so directory, which is present in D drive. Okay, which is present in D drive, bin directory, right? And from this file, I want to access the 10th line. Okay, that is I want to perform a read operation on the 10th line, or I want to perform a write operation on the 10th line, or I want to modify the 10th line. Like that, this file application program may provide some request. Okay, this request is nothing but the logical information. Okay, this request is nothing but the logical information or the logical storage data. Okay, because the user does not know where is file one, and it is stored in which track, which sector, which platter. All these things the user does not know. The user program just say that I want to access the file one, which is stored at d colon bin directory in 10th line. Okay, and then it will be mapped, and the corresponding FZB, the file control block, will be identified, and it will be brought into the memory if it is not already in the memory by the logical file system. Then the file organization module will convert this logical information to relevant physical information. That is, the 10th line of the file f1.txt, what is the corresponding block number. It will convert that data. Okay, it will convert the logical information to the physical physical storage, relevant data corresponding to the physical storage. Okay, so then it will convert it to this particular detail, like which block number should be accessed. and that will be given to the basic file system, and the basic file system will using this block number, it will identify the respective track number, sector number, or plat, or cylinder, and then using that information the device driver uh, will access the particular device, and it will get the work done. Okay, so this is how the content in the files are accessed. Okay, so this is what this layered architecture says. So this is the layered file system. This is how the file systems were accessed. So it is not that the application programs will directly access the files which are stored in the device. No, so it has to follow through these many layers. So this is like several levels of abstraction. This is first level of abstraction, this is second level of abstraction, this is third level of abstraction, this is fourth level of abstraction, like that. It is like a different level of abstraction were provided, and when you go at the top level, when you go from bottom to top, the complexity of accessing the file decreases. When you move from top to bottom, the complexity of accessing the file increases. So basically, the abstract this abstraction is done to reduce the complexity. This abstraction is done to reduce the complexity. Okay, fine. This slide just explains whatever we have discussed so far. So the device drivers, it is the one which directly access the devices, and the basic file system, it gives commands like retrieve content from so and so block, and the file organization module which maps the logical address to the corresponding physical block number. It translates the logical block to physical block. Okay, and and also it manages the free space and disk allocation things. And the logical file system, it manages the meta information. It translates the file number to the file name to the file number, file handle, and also it maintains a file control block. In Unix, the file control blocks are called as inodes. Okay. The logical file system maps the file name to file number, file handle, or the file pointer, and the location of the file is represented through the file control block. This in Unix, the file control block is called as inodes. In Windows, it is called as FCB, file control block. Fine. So this layered architecture was provided to reduce the complexity and redundancy. But the drawback with the layered architecture is it adds the overhead, and at sometimes it can decrease the performance. Fine. So next what we'll be discussing is there is something called as boot control block in the disk, in the hard disk, which contains information needed uh, by the by the computer to boot the operating system from that particular volume. Okay. So what is the volume here? What is meant by volume? So volume means basically we have a initially when you have a hard disk. Okay, what you do when you purchase a hard disk, it is unformatted. Then we partition the hard disk. We partition the hard disk in Windows. If you see, we partition to several drives like C drive, D drive, E drive, EF drive, like that. Several drive depends. Okay, we partition the hard disks into several drive, and then we format. So now each of these are called as a drive. Okay, a disk represents to what? A disk represents to a physical entity. A disk, hard disk, when you say hard disk, it refers to the physical hard disk, actual the physical entity. Whereas drive, C drive, this is a drive. Drive refers to the logical partition. Okay, one particular logical partition, that is called a C drive. Some other logical partition is called as E drive. Some other logical partition is called as F drive. Okay, so drive is a logical entity, whereas disk is a physical entity. Volume, coming to volume, volume is also a logical entity. A volume can be either one partition, or it can be a collection of more than one partition. For example, C drive, you can call it as C volume also. And C and D drive put together, you can call it as a one volume. or C, D, E put together you can call as one volume, or D, E, F you can call it as one volume. Okay, so volume is nothing but a uh, collection of drives, you can say, right? So okay, so there is something called as boot control block, which contains the information needed to boot the operating system. And there is something called as volume control block, which contains volume details. Like this particular volume is formed by how many blocks, total number of blocks, and number of, in this volume, how many free blocks are available, what is the size of the block. We initially we discussed that normally a block size is 512 bytes, but there is no hard and fast rules on that. It may differ. It may differ with operating system. In some operating system, a block size may be 1024 bytes. So in this particular volume control block, the block size is what? Okay, and a pointer to the free block. So all these things also a part of the file system, right? Okay, so the directory structure organizes the files, which includes the name of the file, the inode numbers, inode in the sense the file control block. What are the file control block corresponding to the various files, and also it maintains a master file table, which contains details about all the files. This is how, so for every file there will be a file control block which contains different details about the file. Okay, this file control block is called as inode in Unix, and in case of Unix it will have an inode number, and it will have several permissions. So like who can access the file, and what operation, what are the, who are the different users who can access the file, and what operation they can perform, whether they can perform read operation or write operation or what, and on which dates the file was accessed, on when it was created, when it was accessed, when it was modified. Okay, and the different who is the owner of the file, which groups has access to the file, the size of the file. Okay, and pointers to the data blocks of the file. All these information are part of the file control block. Okay, so the file control block basically maintains the core details about the file. Right. So then we'll be discussing something called as mounting a file. Okay. What is meant by mounting a file? Mounting a file means attaching the file system to a particular directory or a mount point. Mounting a file means attaching a file to a particular directory or to a mount point, so that it will be available to the system. Okay, so if you take in Unix, the root file system is always mounted. The moment you switch on the system, the root file system will be mounted. In case of Windows, if you see, the C drive, D drive, all these will be automatically mounted. And when you open some other directory, this those directories will be connected with the C drive or D drive. In case of Linux, any other file system can be connected or disconnected from the root file system. Okay, so root will be always mounted in Linux, and when some other file systems are opened, it will be connected to root. Okay, when you close it, it will be disconnected from the root. Okay, so there will be something called as mount table, which stores information like what are the various file system currently mounted, and and there will be a pointer for each of the file system which have been mounted, and also it will represent like what is the type of the file. Okay, so the operating system basically maintains a mount table which contains information about the various file system that were mounted. Okay, by default in Linux, the root file system will be mounted. In Windows, the different drives, the top drives, C drive, D drive, all these will be mounted. Apart from that, if any other file systems were mounted, those file systems and their path and the type also will be recorded in this mount table. Fine. This diagram basically shows like how you will, how when the user opens when a user want to open a file or read a file, what happens. So the top diagram, it shows what happens when the user is trying to open a file. When a user is trying to open a file, initially this is the system call which is given from the user space, open a particular file name. So, once it is executed, this control will be transferred to the kernel space. So the kernel space will check in the directory structure. Okay, there will be something called as a system wide file table. So this is nothing but a system wide file table. I'll call it as SWTB, which is a system wide file table. Okay, the system wide file table contains information about all the files that were currently open. The system file table, SWFB. Okay, we'll call it as SWFB. This contains information about all the files that were currently opened. Okay, opened in the sense it might be opened by this process or some other process. Some process has opened this file. So all those information will be stored in this file. Okay. So the kernel operating system will check whether this particular file is currently opened or not. Okay. If it is opened, if it is opened, then it will identify the respective file control block, and if it is opened, then the file control block of that file will be available here. If that file is opened, then the file control block of that file will be available here, and using that file control block, the operating system can access that particular file. Okay, that's it. If it is not opened already, if it is not opened already, then the operating system will search in the hard disk, the secondary storage device, where is this file. So user has given some file, where it is. It will identify that file, will locate that file, and it will identify the file control block of that file, and the file control block of that file will be loaded into the system wide open file table. Okay, so this is how open file access works. So open file is a system call given from the user space, then the control will transfer to the kernel space, then the operating system checks whether it is already opened or not from the system wide file table. If it is already opened, then the operating system can access the file through the respective file control block information. If it is already not opened, then the operating system will give an instruction to the hard disk controller to check the particular file, and then it will get the file control block. It will locate the file control block of that particular file, and then it will be and that file control block will be loaded into the system wide open file table. Okay, so this is how open operation works. Coming to read operation, coming to read operation. So when you want to perform a read operation, the user program will give a read, and then the respective uh, file name or index location of the particular uh, that particular file, which record should be read, some information it will give along with the file name also. Okay, now so now again the control will be transferred to the kernel space, and the kernel space will maintain another table which is called as per process open file table. That is, for each process, how many open files are there, that will be maintained in a table. That table is called as per process open file table. Okay, if there are n process, then for each of the n process, what are the files opened by those process, there will be a separate file table. That file table is called as per process open file table. So for this particular process, what there will be a per process open file table. Okay, so this process want to access some record from one of the file it has already opened. Okay, fine. So that information, first it will search in the system wide file table whether this file is already opened or not. Okay, if it is already opened, it will access that particular data block directly. If it is already opened, then the operating system will have the information about the file control block, and using the file control block, it will access the respective data block. Okay, if it is not already open, then as usual it will find that particular file, it will identify the file control block, it will load it into the system wide open file table, and then it will access. Okay, so this is how the read operation is done. Okay. So partitioning. So as I have already, as we have already discussed, so initially the hard disk will be something called as it will not have any information, and first we have to partition the disk. Okay, partition can be a volume containing a file system or raw. Okay, after partitioning also, your system your after partitioning also, so initially there is no partition in the hard disk, then we partition, like we partition into different drives C, D, E. After partitioning also, you have to perform something called as formatting. You have to format. Only after formatting, some file system can be stored in the particular drive. Okay. So formatting is called as cooked. Formatting means it is cooked. If it is formatted, then it means it is formatted according to a particular file system. For example, if you see Windows, it follows a formatting which is called as NTFS, New Technology File System. Okay, so so like the different operating system follows different style of formatting. If it is not formatted, then it is called as raw. It is raw. So before writing any information, first the disk should be uh, formatted. It should be partitioned and then it should be formatted. And after formatting, there will be, once you formatted, there will be something called as a boot block will be created, which can point to the boot volume. Okay, or the boot loader. Okay, or the boot loader, which contains this set of blocks that contain enough code to load the kernel from the system. Okay, so so the this is so after formatting, so the formatting process will create something called as boot block, which will point to the boot volume or the boot loader, okay, the different terms are used. And this boot loader is nothing but it is nothing but a set of blocks that contains enough code to load the kernel part of the operating system, right? And there is something called as root partition, which contains the operating system, other partitions. The root partition will hold the operating system, and the other partition can hold other informations. Okay, for example, in uh, yeah, in C, in Windows, if you see, normally the operating system will be loaded in C drive. So C drive, you can call it as root partition. And the other partitions where you will be used for storing other